With 34 days until the first public showing of the C1, the team tests Nico's new suspension elements by attaching them to an MV Agusta. The team is on edge as they await the results of the first real track test of the unconventional MotoCzysz suspension design. Any mistakes could mean severe injury or even death to the rider. And in this case, it's Michael Sis.
Today we focus on the bottom end of the front suspension. He'll push the bike as much as he can. You have a very long straight. End of the straight, he'll be at about 270 kilometers per hour, which makes it 170 miles per hour. One lap time will be 1 minute 13 seconds.
Because you'll never run lighter than this. I mean, this could be the bottom of the range, to be honest.
Again? Yeah.
I'll do, yeah.
Yeah, we're locked.
Not on the rebound, yeah.
No, the compression.
But Nico, I'd make the compression the first setting next time.
We should send all the 3 shocks back and have them in various stages. Oh, we only have 2. Okay.
Yeah, because we missed the bracket.
We're changing weight distribution, so we're loading the front end a little bit more, or raising the rear. That gives him a better feel on the front end.
Unfortunately, the whole bike is higher than it was, and it's a little tippy. Yeah, same attitude, to be able to drop it. We can't drop the front on this bike anymore, so we had to compensate by raising the rear, which raised the entire bike up.
He's going way faster. We did a little bit of adjustment on the rear, and that made him more confident on the front. So he can push a little bit more the front, which is a good thing. You can just feel that he's pushing a bit harder, so he's more confident into what he's doing. But only the feedback will really tell us how he feels physically. You need to talk to the rider for that. Morning.
What's up, big man?
How are you?
Good. Kagan, is this the same setup we had in the rear last time? Yeah. It seems softer. It was hooking up like crazy. You have to have apex speed to have that thing compressed before you really start feeling how it moves.
Yeah, and he doesn't feel much difference between the 2 springs, whereas you do.
Yeah.
Which probably means that he's not pushing well enough yet mid-corner to really get that. Indeed, I think it was a very positive test. Not everything was perfect, technically. I'll go into the details. But I think it was very positive by the quality of the feedback we had. The front end, Michael found an adjustment that he liked very much. This adjustment is about the trail, basically. That's the main thing. He's not so happy about the ride height, but we can modify this pretty easily. Negative point was the shock, the front shock, that is not ready yet for what we need. So basically for those parts that will happen between Michael and I will do the changes myself.
Standard cylindrical forks are limited in the amount of flex they give the rider while in the turns. The MotoCzysz unconventional fork design adds more flexibility and control to the suspension system.
Quite likely, it's going to flex a little bit more than the part we had before. If you look at the blade, the section of it, this part here, is not a circle. So this dimension here is way longer than this dimension here. So that's how you can control the flexion differently in 2 directions.
Normally in any kind of testing or any kind of development, there's normally no big, like, Shazam moments. It's normally little bitty steps to reach to an end goal.
Only days from their debut and test ride, Team MotoCzysz works with little to no margin for error. Everything must fall into place perfectly to be ready for the first public showing of the C1.
That'll actually help. You'll be able.
Once he has something that he likes, design-wise, engineering-wise, just, looks and everything, he'll actually bring the sketches to me, show me exactly everything that he's done, how he wants it to look. Then I'll transfer all his information onto CAD, onto SolidWorks, and then I'll model it up, make sure everything works, go over it with him, finalize some details.
In a perfect world, it'd be like this. And you can look at that if you want, which means the flats would be out there.
Right.
But it's going to be quite,
Just be small.
it's going to be really small. And I don't know if it's going to add, work great here.
Now these are counterboard. Maybe we can spot face those or whatever, clean them up to get a better face to mount that bracket
That
on.
would be great. 3 weeks away and we're still kind of don't have the bottom completely resolved. Finish design, go into CAD, get cut, and laid up all within days. An unbelievably concentrated amount of time.
Nico has relied on outside vendors for work on the suspension parts, sometimes with mixed results.
This is the new swing arm. It's made in aluminium. What you see here is a jig for the welding, but the swing arm is this big aluminum part. It's made out of 6 parts, which are the legs, one on each side, the cups, one on each side, and the middle parts, which you can't really see it anymore. Actually, maybe you can still see it, are welded together in the middle. Unfortunately, those parts in the middle are not exactly like what we had specified. The reason for that is that when we welded everything together, those parts in the middle started to crack badly, so bad that we know we will not be able to use this swing arm. The cracks I'm talking about, all the welds have cracked right in the middle. This is not supposed to happen. A weld is supposed to be really beautiful like this. This is a sign that the material is too strong and too brittle. At this point, we still don't know what is the cause of this, and we need absolutely to make sure that this doesn't happen again to the next swing arm, because we have only one chance now to have it right for Laguna Seca.
The second attempt meets with Nico's approval.
This is a new one, so it's all been brushed, and now it's all beautiful. We just have to do the post-machining and then powder coat it, so paint it black, basically. The welder did a beautiful job here to make it really smooth and really beautiful, so it's quite pleasant. The good news is that it's 4.5 pounds lighter than the one you've just seen, so that would be a compensation, but it's still a very, very good start. I'm pretty pleased with that.
A major element in the design of the MotoCzysz C1 is the carbon fiber outer shell. Making the carbon fiber as light as possible without sacrificing strength requires patience and concentration throughout the molding process.
On Monday it became quite hot, so we had kind of troubles with the layup to do it early in the morning or late in the night, because during the day it was about 90 degree Fahrenheit and more, and that's not the temperature you can have when you do a carbon fiber layup, simply because you brush on the surface coating, and the surface coating still needs to be tacky when you start the layup of the rest of the carbon fiber. So it started to react too quick because of the temperature, and it was quite tricky to get the first layer in before this is hardened. Because if it's hardened, you don't get a perfect connection between the surface coating and your layup. it's always the first part is the hardest to mold, because you don't know 100% where's the right point to pull it out.
Well, I walked in there and I was all like gingerly and trying to just take my fingers and lift up little corners of carbon fiber, and I saw particularly the girl Germans on the table with huge like channel locks and pounding and banging on, and a half hour I lost my sense, I got desensitized. The thing that we were most eager to see was this whole shape. I mean, there's a lot of design going on, and we wanted a very aggressive but fluid shape, hard but soft, all those kind of, the dichotomy is when you talk about design. And it came out just spectacular.
There were some areas where it was quite tricky. It was not that it was sticking in the tool, it was just you have big areas where it's not so stiff, and you have the ribs where it's quite stiff. Actually, it's stiffer than I expected it to be.
Yeah, so this is the right-hand fairing. So the rider basically is in this area. There's another one on this side of the windscreen there, and this is the cockpit area that you work from. And in fact, of course, the rider is basically like that. There's, of course, more panels and trims and cutouts and, tons of work to do. But this is amazing stuff. How light it is, just absolutely how strong it is. It's not like we're making big flat panels that can pop out easy. So, we could put more splits in the mold, but Andre is an absolute perfectionist.
Days before the public unveiling of the C1, Andrea is under incredible pressure to rush out a finished carbon fiber frame. Because they're short-handed, she's been forced to farm out one of the key tasks, and it's not up to her standards.
At this, they said, okay, if I would have done this, you would have fired me. And unfortunately, it's true. I wouldn't have accepted something like this. If you look on the fiber direction here, you would have a visual direction with a perfect layup like this. And it's actually like this. And a few degrees of changing the direction of the carbon fiber makes a lot of difference in the strength. And these are just things that make me worried about everything, because I don't want to kill anyone. I prefer to be an than to kill a person riding this bike.
And that's just the nature of making the part to the standards that we want to make them. The last schedule showed that the engine should start being assembled today. That was already some 30 to 60 days from what we wanted at the beginning of the year. But then we just had another slip the last couple of weeks, so we're supposed to start construction on the engine today. It'll actually start on Friday. We'll keep our fingers crossed that happens. And if that happens, that's literally, it's down to days and hours on how long we have to construct it, to mock it up, to dyno test it, to take it, tear it back down, put it back in a bike, chassis test it, tear it back down, and then take it to a track.
With the engine build falling further behind schedule, Adrian goes to check on the monoblock status.
I think the realization that the original deadlines that we had hoped for and the milestones we had hoped for post-design and post-prototyping, when we were actually to start doing track testing, just got completely delayed and completely derailed. It's not a reflection really on the team. It's not a reflection on, we made some bad choices and bad decisions and there's some faulty concepts. I mean, those are still yet to be proved out. We may have done that. We don't have an engine that we can run at full speed, and we don't have an engine you can run at full speed. You just can't do anything.
As soon as we get back today, we'll bring in basically the finished article from the machine shop. We will have 4 more liners to press in, and then there's a skimming operation just to clean those off, and then that is it, ready for build.
Production Tool Manufacturing is a manufacturing firm, and we got hooked up with MotoCzysz through a local tool guy. once they realized who we were and our technical ability and our capacities, not a small shop, but not a large shop, but right in the middle that could handle their prototyping in the onset and flexible with their schedule. Certainly we're committed to that. We were awarded the monoblock.
Getting very close to being finished now. It's a few more operations, a few more assembly operations. So the bore in here for the crank, bore down the bottom for the torque tube, and then another bore here for the idler gear and alternator. Then that's going to be finished. It's pretty good. I guess, I mean, how do you inspect? You can't, can you?
You can check with minor diameters and major diameters next year.
That's about what you can do, isn't it? But in terms of its runoff.
Woo, that looks just like the drawing. Yeah.
It's great. It's the first time I've seen them together, actually, machine. So yeah, it's looking good.
Adrian rushes the engine monoblock back to MotoCzysz for immediate assembly.
After 2.5 months of wait, we finally got our monoblock in. So it was a really great day. We were all excited because it looks beautiful.
That's really good.
Yeah.
Right on. It's good stuff.
Killer, guys.
With all the work that has been going on, it was kind of finally, it felt like that finally something was going to start.
We've seen it through all the steps. You know, it was first sketched out 9 months ago. Seen it in the modeling, seen it in the CAD drawing, seen it in rapid prototype, and we've seen it in the castings. It's just, we've just been so much anticipation waiting for it to get here to stage where we could start building it.
Looks very good.
Really does.
Although the machining work has been done to perfection, Terry Sears discovers holes in the original casting of the monoblock.
It's right under the seat. You can see the crack. Yeah, right there.
Oh, that's a huge problem.
It's a big problem.
Fortunately, we figured out that the monoblock was leaking pretty badly. Just a big mess.
What I think we should do is take and put this in water. Okay.
Definitely. Absolutely.
And then we can tell if we have other problems.
Fortunately, we could not use the monoblock as it was.
Sink up in the bathroom.
So we went from a peak down, we plummeted down to a big valley.
See if we can plug this one up, because if
Actually, I don't have any use.
With the debut only days away, Team MotoCzysz scrambles to find a solution.
I machined identical. But
I think the time and energy put into this trying to fix it would be better put onto another one.
Michelle doing the second one.
Right.
Yes, you stop her from going forward.
Now, the only thing that you could do is perhaps take it to Frank, because he does all this stuff.
Who wants to run it over there?
I'm happy, I know where he is. So
Why
let's
don't you
give
do
him a
that?
ring and do it. And yeah, I'll take it over now.
Just take it exactly the way it
Drive
is.
off and, yeah.
Yep. It's a good idea.
Honestly, if we can find the guy who cut the seats, to be able to yank them out, weld it up, and cut them back in, but that's...
We need the new block as fast as we can have it.
Well, but if we can fix this one faster.
This is not a for sure fixable solution. This is a backup plan. Okay, the way I see this is a backup plan. The real solution is getting a real block.
Yeah, but
in
that's
here
going to be
as
10
fast.
days from now, so it's impossible.
Once the fixture came off of the block, we lost all our reference points. Yeah, no, it's a bit of a setback for us, that's for sure.
We had a number of leaks between the valve seat and the casting, so you could witness that as an air bubble coming out between the two of them.
People running around looking for box, and it was like, what's going on here?
Then just literally went onto the internet with the mil spec and tried to find someone that was as close to Oregon as we could that did the process. That turned out that there was a company in Oakland, in California.
Simon flew down with the engine all wrapped, with the monoblock all wrapped in bubble wrap. He knows that there's a company in San Francisco that does stuff for the military, and they can infiltrate the monoblock with some ceramic coating. So effectively they put some liquid into these cracks, they suck it with a vacuum system, and then it sort of like solidifies and cooks in the little cracks. So it fills the cracks with ceramic.
The costly process of filling the cracks in a precision engine puts Michael and his company in a deep financial bind. He contacts the casting manufacturer.
Hello, this is Mike.
Hi, Mike. Michael Sis from MotoCzysz.
Hi, how are you?
Well, I'm all right. Could be better. All right, let's just get into it. So we received the block. We took it over to Michelle. We did our initial inspection. There were some areas of surface porosity. We really thought it was probably just air bubbles. That looked to be the case. We were pretty optimistic. We dove into it, and after 2 days of machining, we've come up with holes that you can literally stick your pinky into.
Prior to coming to MotoCzysz, saw a large number of castings over an 8-10 year time span. I've never seen anything like this before. I've certainly never seen anything as bad. I want a casting that is 99.9% aluminium, not 90% aluminium and 10% holes. It's clearly unacceptable to us. You know, it will cripple the company if we can't find some sort of resolution to it. There's no way that you're going to put something as compromised as this into a bike whereby if there are any issues with it, either catastrophically because it has failed and you put a rod out the side of your block, or in any other fashion and it dumps all of its coolant or oil onto the back wheel where clearly you're going to put the rider down. Nobody wants to put anybody into that position. We would choose not to put anybody into that position.
To me, I don't think we can keep going down this path. We need to be reimbursed for the machine time that we spent on these blocks, and we need to go someplace that has already done this type of work. But I need to get reimbursed on the work we did so I can go someplace and get 2 engines built. Otherwise, we're essentially done.